Alright, so we're going to start with Chapter 1 and Section 1.1, which is patterns and inductive reasoning. So inductive reasoning is what you're used to in your kind of everyday world of observing patterns and making deductions based on that. So inductive reasoning is based on pattern, and a conjecture is the conclusion you reach. So you observe something happening, you make a conjecture. So if you throw a ball up in the air a couple of times, you would conjecture that it comes down every time. And you want it to be an educated guess as it involves some sort of pattern that you've observed, not just a random guess. So we see down here we have patterns. We have months: January, February, March. We would think the next one is April, then May, then June, right? They're just in order. The next piece is numeric, and we're just counting by twos. So 2, 4, 6, 8, we go 10, 12. And then these are a little bit trickier, but we're looking at squares, right? 1, 4 is 2 squared, 9 is 3 squared, 4 is squared is 16, all the way up, and we can keep going. So a counterexample is something that shows a conjecture to be false. So we might think that we have the pattern figured out, but and we don't. And so we can make counterexamples that disprove a conjecture. So we have a number is always greater than its reciprocal. So reciprocal, right, is 1 over the number if we flip the fraction. So the number can be anything. So let's pick a fraction. So x is a half, which means if I take the reciprocal, that's 1 over x, it will become 1 over a half, which is 2. And is the number, which in this case half, bigger than 2? No, it's not. So that is a counterexample. It's something that's false, so it disproves that conjecture. We also have some drawings that we can look at, right? So we have what's called an isometric drawing, and this represents a three-dimensional object. An isometric drawing is made on isometric dot paper. So you can see that the isometric dot paper is over here, and that's where we have these dots that are spaced out for us. You can see it's not the same as a grid because the distance from here to here and from there to there is different. So it's like these diamonds that we've set up. So if I take a three-dimensional object, in this case we have cubes, and I draw it, we can see those dots, those 7 dots. We'd have one in the back that we can't see. If we connect those dots, then we get our first cube. We do the same thing with the orange square, and then with the green cube as well, and we've reproduced that using our isometric dot paper. So it's an easy way to make three-dimensional objects. Another type is an orthographic drawing, which shows the sides of a structure. So instead of trying to draw it in 3D, which is hard, we think about if we were to take kind of pictures of the front and the sides and the top and how that would look. And so if we were to take our drawing from before and look down from the top view, what we would see would be squares. We'd see a blue square, an orange square, and a green square. And we can put the height of those objects on those boxes. So that would be 1 tall. This is 2 units tall. We're going to assume there's a square back there holding it up. And that one is 1 unit tall. So that allows us to take a three-dimensional shape and give a 2D representation of it. We can also do something called a net. So a net is a two-dimensional pattern that can be folded into a three-dimensional figure. It's often used in the packaging industry. So you start with a flat piece of cardboard, which is 2 dimensions, and you cut it and fold it in such a way that you get something like a box. And we'll look at some examples. So this is something, if we were to take it, would be a cube that's been unfolded. All right. So if we were to fold this back up, we can see that B here is going to come up and be a flap at the top. That's going to become our top. So not A in this case, but B. So this should be a B. And then the front, we'll have to assume that that's going to be F. And again, we could fold this 3 dimensions, so they all could be a top and a side. And then we'd have C and E that are up on the sides, and A is in the back, and D is on the bottom. What we're going to do more often than not, too, is to unfold these solids into a net. So if I look at the thing on the bottom, right, I have a rectangle. And so I would draw that out there. That's my bottom piece. And attached to that are some triangles. So I have a green triangle, and I have another one on the back. So those are the first parts, and then I do also have sides, and I have this piece and that piece, which are again are rectangles, and that gives me my net as I would fold this up.